Welcome to Get Your FRQ On. This question is from 2003, Form B. It's question 4, and it is not calculator active. In the question stem, we have a particle moving along the x-axis, and its velocity for times t greater than or equal to 0 is given by a velocity function. In part A of this question, we are asked to find the acceleration of the particle at time t equals 3. The acceleration at time t can be obtained by using the relationship a of t equals v prime of t. We are given that v of t is negative 1 plus e to the 1 minus t. This implies that v prime of t is equal to negative e to the 1 minus t. Using this, we can conclude that a of 3, or the acceleration at t equals 3, is v prime of t, which would be the negative of e to the 1 minus 3, which is negative e to the minus 2. Therefore, the acceleration of the particle at time t equals 3 is negative e to the minus 2. In part B of this question, we are asked to determine if the speed of the particle is increasing at time t equals 3 and to provide a reason. So whether the speed of the particle is increasing or decreasing at t equals 3 is going to depend on both the acceleration and the velocity of the particle at t equals 3. Now, note from part A, we've already determined that the acceleration at time t equals 3 is negative. So what we need to determine is the velocity at t equals 3, which is negative 1 plus e to the 1 minus 3, which is negative 1 plus 1 over e squared, which is also going to be negative since 1 over e squared is less than 1. Since we've concluded that the acceleration at t equals 3 is negative and the velocity at t equals 3 is negative, the speed of the particle is increasing at time t equals 3. In part C of this question, we are asked to find all values of t at which the particle changes direction and to justify our conclusion. The particle will change direction whenever v of t is equal to 0 and also changes sign. Solving the equation v of t equals 0, we get negative 1 plus e to the 1 minus t equals 0, which implies that e to the 1 minus t is equal to 1, which implies that t is equal to 1. We need to determine if v of t actually changes sign there, so we will analyze v of t. V of t is greater than 0 implies that negative 1 plus e to the 1 minus t is greater than 0, which implies that e to the 1 minus t is greater than 1, which implies that 1 minus t is greater than 0, which implies that t is less than 1. In addition, v of t is less than 0 implies that negative 1 plus e to the 1 minus t is less than 0, which implies that e to the 1 minus t is less than 1, which implies that 1 minus t is less than 0, which implies that t is greater than 1. Since v of t does change sign at t equals 1, we can conclude that the particle will change direction at t equals 1. In part D of this question, we are asked to find the total distance traveled by the particle over the interval from t equals 0 to t equals 3. The total distance traveled by the particle over the interval from 0 to 3 can be found with the integral from 0 to 3 of the absolute value of v of t dt, which would be the integral from 0 to 3 of the absolute value of negative 1 plus e to the 1 minus t dt. Now, because this is not a calculator active question, we're going to have to evaluate this integral by hand. Notice that the cusp will be at x equals 1. So to integrate from 0 to 3, we want to split this as two integrals. The integral from 0 to 1 of negative 1 plus e to the 1 minus t dt plus the integral from 1 to 3 of 1 minus e to the 1 minus t dt. So we get negative t minus e to the 1 minus t evaluated between 0 and 1, plus t plus e to the 1 minus t evaluated between 1 and 3. So we get negative 1 minus 1 plus e plus 3 plus e to the minus 2 minus 1 minus 1. And after we evaluate all of that, we find that the total distance traveled by the particle over the interval from 0 to 3 is e to the minus 2 plus e minus 1. If you like the AP Calculus free response question solutions and want more of them, don't forget to like the videos, subscribe to the channel, and you can also find me on X at x.com/getyourfrqon.